Okay, so today we're doing the cosine rule. So this is like the sine rule we did in terms of it can be used on a triangle that's not right angled. So this is a different to the Sokotoa rule because the Sokotoa rules you can only use on a right angle. This one we can use on any triangle. So generally when we see, if we're not sure that a triangle is right angled, we would use this cosine or that sine rule. So the cosine can be, so we said that. Now you can use this cosine when we are missing a side or an angle. So if you have a look here, they have labelled this triangle up the same way that we label with the sine rule. So if you call this corner angle A, then the side opposite becomes side little a. So that's to help us when we set up the rules, and the same if that was B, that became B, and so on, C across there. So it doesn't matter if you have which one you call A, B and C, but as soon as you call one angle A, the side opposite has to be the little a. So then if you have a look here, we've got these rules here, and here's the rules. Now this is if you were trying to find a missing side. So say for, well, we'll see in a minute. So this first one here is if we were missing side A, so this angle, this side here, sorry. And B's the setup of the rule if we're missing side B and so on. Now down here, these are the rules that we use if we're missing the angle. So if we're missing the angle, we use these rules. And we're just going to use nsolve, and we just set it all up as normal. So we'll go to the next page and have a look at this one here. Yeah. Back here, this one. Okay. So I'll check that was right. Yeah. The examples here. So if you read in here, find C, so side C, to 2 decimal places. So these are the things you should be underlining when you're doing them in your tests as well, so that you know, of the triangle shown. So they've already labelled little c, so this one's little a and this one's little b. Now because we're looking to find the side C, we're probably going to use the C rule. So C squared, if you go back and, so C squared equals A squared plus B squared minus 2AB cos C. All right, so you just substitute in everything that you know. So we don't know what C squared is, so we'll leave that there. We know that A is 34, so we'll square it, plus B is 27 squared, minus 2 times 34 times 27 times cos, and make sure our calculators are remaining in degrees when we do this, and cos 50. So you guys can put in the nsolve, you can put in the nsolve at this point, yeah, and comma C, and we should get it. So we'll go look at that on our... Okay, so we've done that on our calculator. It's not so crucial that you do n in these ones, but it's more when you're trying to find an angle. But solve anyways, it doesn't hurt. So C equals, now it said 2 decimal places. So for me, it was 26.55, and they didn't have any units, so I'll just leave it like that. So then we can do the next one. It says for the find the largest angle correct to 1 decimal place of the triangle below. Now, do you know, where do we find the largest angle? Do you know? I remember I've told you before. The largest angle is always opposite or the largest side. Yeah? So if you think about it, in a right angled triangle, 90 degrees would be the largest angle you could get, yeah? So in a right angled triangle, and what's opposite the right angle in a right angled triangle? A hypotenuse, which is the largest side. But in these triangles, it's still the same. So find the largest angle. So because 6 is the largest side there, A is going to be the largest angle. So you know that you need that the angle A rule. So if you write out your rule, so cos A equals B squared plus C squared minus A squared over 2BC. Okay? And so then you just plug in everything you know. So you can see when you know all the sides, but you don't have any angles, that's when you would use this cosine rule to find an angle. So we just substitute in. So cos A is what I'm trying to find. B, here's little b because it's opposite. This is little c. So I've got 4 squared plus 5 squared minus 6 squared over 2 times 4 times 5. So just pop in n solve again. Now you want to put n solve because you're finding an angle, comma A, because we called it big A, and you should get the answer. Let's go. So for this one, I got that angle A was, now it said to 1 decimal place, so for me it was 82.8 degrees. Okay, so that's pretty good. It's a large, it was the largest angle. All right, so I'm going to do this one now. So this first one, it was just find the distance between A and B. So that is this side, this line here. So if you draw out what you've got, just draw the triangle that you've got here. So we know this is 30, we know this is 4, this is 6, and they want to know this side here, which I'll just call X. So you can call this A, B, and C, and then if you label it up like we normally would, so we would want side C in this situation. So I'm going to write the formula for C, which is C squared equals A squared plus B squared minus 2AB cos C. You guys just look up on your formula, like go back and have a look on the formulas. Yeah, I know them because I've done them lots of times. But just be sure and check. All right, so then we'll substitute in. So we know that A is 4. We know that B is 6. So we're writing all that in. Cos, and it's 30 degrees. And then into our calculator, we can put solve, comma X. Just make sure that this is a squared there. Even though you're just finding one, the formula is X squared or C squared. Lots of kids miss that, and that's where the little error happens. So if we go and do that one. All right, so I just did that one on the calculator, and I get X to be, the question doesn't say how many decimal places, I'll just do one. So I get it to be 3.2 kilometres. So if you have a look, just always look to see if it roughly makes sense. So if that was 3.2 kilometres, that looks okay, doesn't it? Because that's 4, that's 6. We're not an unreasonable looking distance or length there. It's always good, it will help if you do those things. It helps you spot if you've accidentally done something wrong in your working out. All right, so let's have a look at the next one. A yacht at left point A and sailed 15 kilometres east to point C. So see how here, remember we talked about it with the bearings, we should set up the compass, and then we said that it took off east, so it went exactly along the east line to C. And this is where we should really, when I want you guys to do this, to start putting in a nice light little compass on your next point, because that helps you see those parallel lines if you need to do it. Okay, so it sailed left. Another yacht started at point A and sailed 10 kilometres to point B, shown in the diagram. So it's gone up here to point B. So we should really try to put a little compass on that as well, just because it will help if they're going to ask a bearing question. Okay, the distance between, so they've done those distances there is 12 kilometres. What was the angle between their directions as they left point A? the angle correct to 2 decimal places. So what they're actually asking for there is this angle here, okay? That was the direction of one guy and that was the direction of the other one, so they want the angle in here. This is question A. So just simplify the diagram for yourself if you want to, because it'll make it easier. You've got a triangle like that, you want X, you've got this one's 10, this one's 15, and this one's 12. And so if you just want to, oh, they've already labelled it A, B, C. So A, B, C. So if you were putting your little sides, this is little A, this is little B, and this is little c. So they want angle A for that first one. So you write out the rule, cos A equals B squared plus C squared minus A squared over 2BC. And, sorry, this is for part A. And then you just substitute the numbers in. So cos X so 15 squared plus 10 squared minus 12 squared over 2 times 15 times 10. Okay, so we're going to find out what X equals on the calc. Okay, now I said I found the angle, but I'm checking to see. It says 2 decimal places. So I found that angle to be 52.89 degrees. It's very uncommon, I'll just let you know, in an exam, in VCE exams, for them to ask for an angle to 2 decimal places. Normally they just say round to the whole degree. We don't like to talk like that. So I'm not sure why the book keeps doing this, but maybe just to practice you looking at reading the questions. But normally we do that, so that would be 53. All right, okay, so in part B, we need to find the bearing of point B from the starting point A. So what you've got to do when these bearing questions come, you're looking for from A, and that's where you want to start from. So we're at A, and we want to go all the way from its north line until we hit the line that's joining A and B, which is here, yeah? So there's B. So if you're trying to find the bearing, you need this little number. Oh, I should call it a different letter. We need Y in there. Now, if you remember back to this question, it said that A is east, so that's dead east there. So if you're on the actual east line, that means that's 90 degrees, doesn't it? Yeah? And you said this X was what we found, which was... I'm just going to round to one whole, I'm going to round to a degree, which is 53, yeah? This one. So therefore, what wouldn't Y be? Wouldn't Y equal 90 minus the 53? Is that true? Yeah, so what's that going to be? 37, yeah? Now, just be careful, when they say bearing, we should really put a 3-digit number. So what would I put? Yeah, so the answer should be 037 degrees. So you could say that, or you can say that it's north 37 degrees what? Did I go east or west? East, good. You could say that. But I pretty much do these ones, they like these answers. All right, there you go. Let's go look at this last question here. So, and this is where you might get asked the bearing question. So a bushwalker left base camp and walked 10 kilometres in the direction of 70 degrees. So remember when I said when you start, so this was the start, and you draw your compass. If he's walking it on a bearing of 70 degrees, that means you go from north and you go until you hit 70 degrees. So that's why they're saying that. And he walked on that bearing out 10 kilometres. His friend also left the start of base camp and walked 8 kilometres on a bearing of 120. So you can see all of that is 120. So find an angle between their paths. So can you see, if to here is 70, but to here is 120. Yeah, what's that one in there is going to be the difference, isn't it? Can you see that? It would be 120 minus 70, wouldn't it? Because up to there is 70, so wouldn't it be the difference? Are you happy with that? So what would that be? 50? Yeah? All right, so I'll rub all that out so you can see that. So we now know that A is equal to 120 minus 70, so that's 50 degrees, yeah? So you've done that one. That was a bit easy. How far apart are they when they stopped walking? Give your answer correct to 2 decimal places. So they want this distance here. Okay, so just draw out what you've got now. Like if you look, I don't know, something like this. So you've got A, B, C. They said this is 10, this is 8, and you now know this is 50 degrees, and you want to know that. So if you were labeling your little sides, you want the A side. So write the A rule. So A squared equals C squared minus 2BC cos A. And then substitute in what you know. So x squared equals 8 squared plus 10 squared minus 2 times 8 times 10 is cos 50. And obviously, same, pop it into the calculator, just use solve, comma x, and we'll get our answer. Okay, it said 2 decimal places, and I got 7.82 kilometers. So I'm just going to go have a look, and if that was 7.82, I'm fairly happy because they're saying that one is 10, so that's a longish looking side. Just so you roughly think you're okay. So say you came out with 17, that's wrong, is it? Like, it just looks wrong, so go check your work. It could be, but you just want to check your work. That's a good way to trigger. Otherwise, we'll just do the same mistake, yeah? This last one was taken out of an exam, a VCE exam, I'm pretty sure. So in a game of beach soccer, a player at F is attempting to kick a goal. She is 6 metres from one goal post, G, and 8 metres from the other goal post, H. From where she's standing, the angle through which she can shoot at the goal and still score is 19 degrees, as shown. The distance between G and H is, so if you just drew your triangle out, I don't know, just like what they've got there, they've said that's 19, they've said that's 8 and that's 6, and they want you to find that. So if you want, just label it like we're used to. So that'd be little a, little b, little c. You want this, so you use the A rule. Which is that. And then just substitute in. So you can see it starts getting really repetitive. And hopefully just use your copy and paste on your calculator. It will save you a little bit of time. Okay, and solve, and let's go. And it doesn't say how many decimal places. I think this was a multi-choice, but we'll go work it. Okay, so I get that distance to be 3.04. So they are calling it GH, so you might want to answer with that. So 3.04. How many, that's meters. How many meters is a soccer goal? Does anyone know? Roughly? Jackson? What good are you? All right. So I think 3 meters is pretty good. So that seems reasonable. All right.